Hi there, fifth grade. It's time for science. As you know, in our unit, we're reading about engines and energy. And so you worked really hard last week on your own. I'm looking forward to getting all of your science comp checks and grading those. And we carry on, praising you for all your hard work. So today we're going to look at pages 168 to 171. And we're going to learn about the power of internal combustion. Okay, we're going to talk about internal combustion engines and external combustion engines. I'm going to do the best to explain it on YouTube from afar. It's so much easier to teach when we're together, but I'm going to do the best that I can. Okay, so the first thing I want you to do is look on your templates, and let's look at our questions so we can look at some of the key terms. All right, so I'm on page 171, Comp Check 6.7. The questions are: number 1, what is combustion? Number 2, what are the 2 ingredients for combustion? Number 3, what type of engine burns fuel inside the engine? Number 4, what type of combustion engine is the steam engine? Number 5, the burning of fuel releases chemical energy in what 2 forms? Number 6, what does a gasoline's octane number indicate or mean? Number 7, list the 4 strokes in the cycle of a gasoline engine. Number 8, the oil used in the lubrication system of an engine combats the effects of what force? And number 9, name the type of internal combustion engine that best fits each clue. Clue letter A: hot compressed air ignites the fuel in the cylinder. And letter B: a spark from the spark plug ignites the fuel in the cylinder. Okay, so let's look back at page 168 and let's read it together. All right, remember to look for the dark bold print. That's important information and highlighted information. So the power of internal combustion: fuel and oxygen, ingredients for combustion. So it talked about what is combustion. I have a feeling it has to do with fuel and oxygen. So let's find out what causes combustion. So the word combustion is just another name for burning. If we say that something is combustible, we mean that it will burn. If something is non-combustible, it will not burn. Fuels, such as gasoline, oil, coal, and wood, are very combustible substances, meaning they will burn easily. An internal combustion engine is one in which fuel is burned inside the engine. The steam engine, on the other hand, is an external combustion engine because its fuel is burned outside the engine. All right, that's pretty self-explanatory. Chemical energy is a special form of potential energy which is stored in fuels. Burning allows the chemical energy to be released. Some of the released energy takes the form of light energy, which we see as a flame. But most of the energy stored in the fuel is changed into heat energy. If you have ever stood next to a bonfire, maybe you're at the beach at Dockweiler and you're doing a bonfire on a Friday night or a Saturday night in the summer. I know that my family, we like to do that at the end of the summer every year, and it's always a great time. What I know is at a bonfire that it gets pretty hot, depending how much fuel you have on it. So, meaning wood. So if you have ever stood next to a bonfire, you have felt the heat energy released by the wood fuel. What's the fuel? Wood. Heat energy can be transferred to other objects as kinetic energy to do work. In the steam engine, for example, the heat energy released by the burning fuel is used to change water into steam, and the steam moves the piston. Okay, so we talked about the 3 states of matter, which is a liquid, a solid, and vapor, water vapor, or steam, in other words. So a steam engine creates steam because the fuel, the coal, is ignited, it gets hot, and we'll throw like water on it, and that produces the steam. You throw water on hot coals, steam is going to come off of that, and that propels the steam engine forward. Okay, that makes the wheels turn, in other words, gets the engine going. And that does that by moving the piston up and down. The piston attached to the wheels, chugga, 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 right? And the choo-choo that we heard is when the steam comes out of the smokestack. Little acting for you there. Fuel must have oxygen in order to burn. Okay, you cannot burn anything without oxygen. The needed oxygen is taken from the air. Burning fuels require a good supply of fresh air because they use up oxygen very quickly. When fuel burns, it combines chemically with oxygen to form hot, expanding gases. Hot gases take up much more space than cool gases. The hot gases from burning fuel heat up the cooler gases in the surrounding air, and these cooler gases also expand greatly. The internal combustion engine is a device that harnesses the power of those expanding gases produced by burning fuel. Harnesses means like it gets a hold of it, to use it, okay? To propel whatever you're propelling forward in the engine that you're using, like a car. We're going to talk about that. So, in an internal combustion engine, a mist of liquid fuel is mixed with air and ignited inside a cylinder. The oxygen then in the air allows the fuel to burn. All right? Now, in what we just read, if you have any questions, anything wasn't clear to you, you know that once you've read everything and you give it a shot doing your comp check, that you can reach out to me through FaceTime or calling me or email, and I'll do my best to explain it to you remotely, meaning from my apartment, okay, and from your home. I want you to know, you ever have questions, you can talk to me about any of it, all right? So let's move along. The gasoline engine, I'm on the bottom of page 169. What gasoline is? When we just read about in an internal combustion engine that the liquid fuel hits is mixed with air and ignited, meaning lit, inside a cylinder, we know that liquid fuel is more than likely gasoline if we're just in a typical car, okay? So that's what they're talking about there. So let's talk about what is gasoline then. Most automobiles are powered by an internal combustion engine that burns gasoline as its fuel. Gasoline is what a typical car needs. Gasoline is a mixture of hydrocarbons, which are chemical compounds, different chemicals mixed together, derived from petroleum, which we know is oil or crude oil, by refining. Besides hydrocarbons, other chemicals are also added to boost the fuel's performance. Gasolines are graded by their ability not to explode too soon or too suddenly while being compressed within the cylinders of a gasoline engine. Such explosions waste energy and they may damage the engine and cause an annoying knocking, it says, in quotes, or pinging sound. This ability to resist knocking and to burn smoothly is a gasoline's anti-knock quality indicated by its octane number. So if you look at the picture there, you'll see a typical gas pump. Okay, maybe I'm sure you've been with your parents when they bought gas. And they have unleaded and then unleaded plus and then like a super unleaded or a premium gasoline. Most of us just use the regular unleaded. It's the cheapest. And we don't have, for the most part, high-performing cars. We have typical cars, like I just have a typical car. But the race cars and maybe really exotic or really expensive fancy cars will have and probably use premium gasoline because it's better for the engine and it causes the car to perform better with better excellence. We don't need that too much just driving through the city, but a high-performing car, like you can see the fancy car right there, like a Ferrari or a Lamborghini or maybe some of your dream cars. You're going to want to put the premium gas in so it will have a higher quality and being better on the engine and make it higher quality as far as performance. Okay? So the higher the octane number, the greater is the anti-knock quality of the gasoline, meaning it's going to give you that higher performance. Regular gasolines have lower octane numbers than premium gasolines. Okay, that's what I just explained to you. And like I said, in a standard car, you don't really need anything that's of a premium. It's totally up to your folks, and will be up to you when you get your car. But I just put regular gasoline in my car. Okay, so on the top of page 170, we're going to learn now about four-stroke engines. Okay, and it gives you illustrations. So as I read about it, I want you to follow along and look at the illustrations. This is the best way to teach it, is by looking at the illustrations. I tell you all the time that most of us learn visually, meaning by seeing something. So while I'm reading, you could be looking at that, and that should become clearer and clearer to you as to what they're trying to express and illustrate. All right? All right, so I'm on page 170. It says, inside a gasoline engine, a typical gasoline engine, like our cars, most automobile gasoline engines have pistons that move up and down or back and forth in the cylinders and operate on a four-stroke cycle. We talked about cylinders earlier in this unit. A stroke is a single movement of a piston. Whether, let's say this is my piston. I'll use my whiteboard pen. A stroke would be, does it go up and down? Single, 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 single. So a single movement, or it said back and forth, side to side. Okay, side to side. One stroke, another stroke, one stroke, another stroke, one stroke, another stroke, one stroke, another stroke. And that is part of what causes the car to move. Okay, so you can see that in the picture. You'll see arrows that show the way that things are moving in the four-stroke engine. You'll see the white arrows there in the illustration above. So it says the first stroke is the intake stroke. The piston moves down and draws a gasoline-air mixture from the carburetor or fuel injector into the cylinder. Okay, so it is going to feed the cylinder gasoline. Okay, in the compression stroke, so the intake stroke, take in the gas. In the compression stroke, the piston moves up the cylinder and compresses the gasoline air mixture. So we see here in stroke 1, going to do my best, you can follow along in your book. It takes in the gas, you see the arrow, it's taking in my mixture of fuel and air. It's putting it into the cylinder. This is the cylinder, the round part here. And then in the compression stroke, it's pushing it up. It's compressing it to feed it out into the engine. Okay, so hold that in your mind and you can continue looking at your picture. Now, so I'm going to read that again. The first stroke is the intake stroke. The piston moves down and draws a gasoline mixture from the carburetor into the cylinder. In the compression stroke, the piston moves up the cylinder and presses the gasoline-air mixture together, like in the picture. At the top of the compression stroke, the spark plugs ignite the compressed mixture and the burning. Expanding gases pushes the piston down for the power stroke. And in the fourth and final step, the exhaust stroke, the piston moves up, pushing the burn gases out of the cylinder. Okay? So, like I said, we bring it in the intake stroke, bring our mixture of fuel. It goes down into the cylinder. Then the compression stroke, phase 2, pushes it up into what did it say? The spark plugs, I believe? Yeah, that's what I thought. Into the spark plugs. Okay, spark, you see the spark, is now going to come down into the power stroke and then out. So we see out into the exhaust. So remember we talked about the stroke? Boom, 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 boom. Those four things are happening. First it comes in, the stroke goes down, then the compression stroke pushes up, then the power stroke goes down again, the spark plugs ignite, it goes down, and then the exhaust stroke pushes it back up. I'm using as basic of terms as I can to explain it. So I hope that's helpful. But you can see the picture there. That's what causes the up and down, the movement up and down. Now, so let's continue. As the gasoline-air mixture burns, energy is released that moves the pistons and transfers power to the crankshaft. In an automobile, the crankshaft's rotary or spinning motion is transferred through the drivetrain to the car's wheels, and the vehicle moves. Besides the gasoline engine and the drivetrain, other important components of the internal combustion engine are its cooling system and its lubrication system. Okay, so we see here, this is the crankshaft right here. Remember, this is all one cylinder. It's not like your car has 4 cylinders. It's just showing you what is happening in each stroke. Okay, but for the sake of this is, they're talking about one cylinder here that they are illustrating, and what it does, the form movement that it makes. And then the crankshaft is going to do what? Look at the arrows. It's going to turn all the way around, all the way around. It's going to rotate all the way around. And then the tires do what? Go around and around and around and around and around. Okay? So now there's 2 other very important parts, the lubrication system and the cooling system. Imagine if your engine didn't have a cooling system and all that fuel is being compressed into the 4-stroke engine. Okay, the 4 strokes of the engine, of the gasoline engine, which we know is combustible. We learned about that in the beginning of what we read. And combustion means burning. If there was no way to cool it, we're going to be in trouble. It's going to explode. Okay, and also each stroke needs to be lubricated, because if it doesn't, there's going to be friction, and that's going to cause sparks, and we do not want sparks. Oh, and it's going to wear it down, and we do not want sparks when we have fuel, okay? Because we know that it burns. So we don't want sparks around fuel. So let's learn more about that. It says the cooling system uses water and air to keep the engine from overheating as the engine operates and fuel burns in the cylinders. Okay, very important. So, like I said, we need it to stay cool so it doesn't literally burn in a way that's dangerous. All right. So, the lubrication system keeps rapidly moving metal parts, like I said, in the engine from becoming too hot or wearing away as a result of friction. A coating of oil covers the metal parts and makes them slippery. So the oil is the lubricant. The slippery oil reduces the friction between surfaces as the parts rub against each other. Okay, so if I had my pencil and I wish I had like an actual engine here, but I'm doing the best I can. My pencil and my whiteboard pen, and it's rubbing, and both of these are metal. It's going to spark, wear away, get really hot, and we know that heat combined with fuel is dangerous, obviously, and so we have a lubricant. So if these are both covered in in oil, they're going to just slide really nicely without causing any friction, any heat, any wearing away. Okay, so you need oil. That's why cars need oil. And you know that your parents, maybe they'll go to Jiffy Lube or whatnot to change the oil, and they'll do that like every 3,000 miles. That's what I try to do, so that that everything's lubricated really well in the engine, and all the rubbing back and forth doesn't cause a problem. Okay? All right, so let's turn the page and let's talk about the diesel engine. The importance of diesel engines. A second type of internal combustion engine is the diesel engine. Because of its greater efficiency, the diesel engine is preferred to the gasoline engine for performing heavy-duty work. Like you'll see a semi-truck, it's going to use diesel gas compared to maybe a regular car, like the cars that we drive. Higher, not higher performance, but greater efficiency, okay? So, heavy duty work. Earth movers, you can see the picture there of the kind of machines that use diesel gas for greater efficiency. Okay, so earth movers, tractors, road graders, bulldozers, power shovels, semi-trailer trucks, like a diesel truck, like I said, mini ships, railroad locomotives, cross-country buses. These and other large vehicles and heavy machinery are equipped with diesel engines. Diesel engines are also used in some automobiles and in electric power plants in smaller cities. Inside a diesel engine, unlike a gasoline engine, a diesel engine produces no spark. Remember we talked about the spark plug here in stroke 3? It uses no spark, okay? To ignite the fuel air mixture in its cylinder. Instead, the diesel engine relies upon the principle that when air confined to a cylinder is suddenly compressed, its temperature rises. Okay, when it's suddenly compressed, the temperature will rise. This rise in temperature to about 900 degrees Fahrenheit is hot enough to ignite the fuel that is then injected into the cylinder. Okay, which we saw here in stroke 1. When the fuel is injected, it's hot enough because it is compressed very suddenly. So the diesel fuel explodes violently, creating temperatures as high as 4,500 degrees Fahrenheit and pressures as much as 1,500 pounds per square inch as the expanding gases push the cylinder down in the power stroke. And that's what helps move forward something that's as heavy as a train or a tractor or a bulldozer, okay? So now make sure that when you do your comp check that you look at the words in bold. Any questions that you may have, you can text me or you can FaceTime me or you can call me, email me. If by any chance I don't pick up my phone, it's probably because I'm with another student. I'm having my phone with me all the time and I'm in my home all the time. So I am here for you at all times. But if you can't get me right away, know that it's probably because I'm with another student. Okay? Now, also, if you have anything that you are wondering about, like I said in what we read, or maybe you have some comments, something you want to share with me, something that you've seen, you know, of your own. Maybe you know somebody who has a diesel car. I had a friend who had an old Mercedes-Benz and it used diesel gas. So just if you want to talk to me or make comments, because that's the thing about being far away, I can't hear from you. I want to hear about that too, not just if you have questions. So if you want to share something with me about anything that we've read. And I appreciate your patience as I'm learning how to teach without having you right in front of me. If I mix up my words here and there, or like I said, if I have to look down because I'm reading, I appreciate your patience and your grace. This is all really new to me. I'd much rather be with you. We're going to be together again soon, believing for that, praying about that. But so I hope you learned something today. I always learn when I teach you. I love you guys, and I will see you tomorrow when we talk about our next Science Comp Check 6.8, which, I have it right in front of me, is the power of jet propulsion. This will be really cool if you like planes and jets. And then 6.9 is all about rockets. So I'm sure you'll have fun things to share with me. All right, so I will see you very soon. You're awesome. I miss you. Bye-bye.